both the nodes, node x1 and node x2, and let's write them as 1 and 2. So in these two equations, we have to find out the transfer function using these two equations. So for transfer function, we have to find out the Laplace transform, and after getting the Laplace transform, we will find out the ratio of the output and the input. So transfer function will be, input is our x1 and our output is x1 and input is the force. So getting their Laplace transform, we will get their ratio, we will get the transfer function. So first take the Laplace transform of the first equation. We have this as, the Laplace transform of ft will be fs. We have m2 d2x1 by dt square, so it will be s square m2 x1 s. Be s square m2 x1 s, plus we have b2 dx1 by dt, so it will be s b2 x1 s, plus b dx1 by dt minus dx2 by dt, so it will be s x1s minus s x2s, so it will be plus we have this k1 x1 minus x2, so it will be So this is the Laplace transform of the first equation. Now rearrange the terms, we will get fs equals to s square m2 plus b2 s b2 plus, first accumulate or collect the terms which are having x1s. So x1s, here also we are having x1s, so it is sb. Here we are having k1, so this whole is multiplied with the x1s taken as common. Now for x2s we have minus, then we have bsb, and here we are having minus k1 x2, so we will have here plus k1 and x2s is taken as common. So this is the Laplace transform of first equation, number it as third. Now take Laplace transform of the second equation, we will get, we have here k2 x2, so it will be k2 x2s plus m1 d2 x2 by dt square, so it will be s square m1 x2 s plus b1 s x2s plus k1 x2s minus x1s plus b, we have dx2 by dt minus dx1 by dt, so we will get s x2s minus s x1s, and this is equals to 0. So if we collect the terms having the same, we will get, collect first x2s, so we will get k2 plus s square m1 plus b1s Now collect for x1, we have this term k1, and here we are having minus bs x1 is. So we will get minus here also, minus here also. So we can take minus common. Then we can have k1 plus bs x1s equals to 0. Okay, so this is our fourth equation. We have got the Laplace transform of both the equations. This is third equation and fourth equation. So from these two equations we will get the value of x1s. When we solve these two equations, we will get x1s as x2s we have just shifted this term to the right hand side, and then we have taken the value of x1s will be this term upon this term. Okay, so we have got x1s, and x2s it will be we will multiply this term here and this term will come in the denominator. So we have this equation. In this equation we are having x1 value also, x2 value also. So putting these values and then getting the ratio, because we have the value of x2 in terms of x1s, and we have to find out the ratio of the Laplace transform of x1 and the Laplace transform of f, that is the force. So we will put the values of this x2 into this equation, third equation, and then we will solve it. So we will get fs plus sb and plus k1. We were having this. Okay, then x1s, and then minus we have this k1 plus bs into x2. So in this x2 term we were having k1 plus bs also here, so it will come in square. Okay, so we have this as minus. We will put here sb plus k1 x1s, and putting the value of x2 k1 plus bs upon this m1 . So we have put the value of x2 here. Now solving this and getting the ratio, we will get fs, or we will get x1s by fs as so we have got the ratio of the x1 and fs, and this is the transfer function of the system. So we have solved the problem. I hope you have clearly understood it. Thank you.